Now we want to add to this what's going to be our final transformation that we're going to look at, the horizontal the horizontal shifts to the left and to the right. But for trig functions, they call this the phase shift. Sometimes they talk about waves like sound waves, light waves being out of phase with one another. So they call the horizontal shifts a phase shift. So if you have the most general form that we're going to look at here, y equals a times the sine or cosine of k times x minus b, then you still have the amplitude of a, the period, 2 pi over k. And now if we're replacing x with x minus b, we get this phase shift by b. Now it has the opposite sign by name here. If the graph moves to the right, toward the positive direction, we say it as a positive phase shift. Like if you had x minus pi, the phase shift would be pi. And if you had x plus pi, the phase shift would be negative pi because it moves toward the negative numbers toward the left. Okay. So you have to draw one complete period of this. You could draw other periods, but it's very strongly recommended you draw where would that original period from 0 to 2 pi over k go, and if you shift by b, it would go to b plus 2 pi over k. So that's the way we're going to try to draw our phase shifts. Sometimes that's easy if it's really compatible with your scale. Sometimes you have to get a common denominator and divide it up a little more. So let's look at an example here, kind of a nice general example. So we have y equals 2 sine of 2 times x minus pi over 2. So the amplitude is the a value, which is 2. The period is 2 pi over 2, since we have a 2 in the front here, which will be pi. And then we would say we have a phase shift equal to pi over 2. The graph has to move to the right by pi over 2. So I always try to figure out what would this look like before I do the phase shift. So the period's pi, that means pi over 2 is halfway. We need to move it by pi over 2. That's not going to be too hard to do. Now, I'm only going to label those tick marks, but add a couple more. So the amplitude is 2. So I'll label my y-axis appropriately here. So let me draw it first without the phase shift. If we ignored the pi over 2, we're drawing sine. Now that we have our scale set up, we just have 0 to the amplitude to 0, then to negative 2 to 0. And then to do the phase shift, we move everything forward by pi over 2, which we can just count tick marks here. And there's our new graph. Again, it's periodic if you keep going. But one complete period I would draw from pi over 2 to 3 pi over 2. And I don't always label every mark on the axis if we can figure it out. But oops. That would be 3 pi over 2. Okay, let's try one with cosine now. So we have y equals 1/2 cosine of 3x, not in factored form here, but with 3x plus 3 pi over 4. There is something we're going to have to be very careful of here. So this is not really in the standard form yet. We need to factor a 3 out on the inside so that we can see the proper phase shift. So the form is a times sine or cosine of a times parentheses x minus the phase shift. So if we factor 3 out, we're left with x plus pi over 4. Okay. If we went backwards, we'd have 3x plus 3 pi over 4. So now we can see the amplitude is 1/2. The period, this one's a little weird, it's 2 pi over 3, so not going to be a nice multiple of pi there. We get 2 pi over 3. And the phase shift, I'm going to abbreviate, would be negative pi over 4. This one needs to go to the left by pi over 4. That's not the easiest thing to do here. Let's draw the graph first without the phase shift. So our period is 2 pi over 3. If we divide by 4, 2 pi over 3 times 1/4, we would have pi over 6, 2 pi over 12, or pi over 6. So each tick mark is pi over 6. We're going to need to know that to figure out what pi over 4 is. But again, let's ignore the pi over 4 in the phase shift first. We've got an amplitude of 1/2, so I'm going to label my scale -1 to 1 with the extra tick marks for the half. So cosine, if we didn't do the phase shift here, we would be at 1/2, 0, -1/2, 0, 1/2. And then we just need to move this thing to the left by pi over 4, but we have to look at our scale, which is pi over 6, and what we want to do, which is pi over 4, we're going to need a common denominator of pi over 12, or a common denominator of 12. So if we multiply by 2 over 2, pi over 6 is 2 pi over 12, and pi over 4 would be 3 pi over 12. So I can go in here and cut up my axis a little more so that each of those tick marks is pi over 12, and I got to go back 3 of those. And then we simply do that, move each tick mark back 3 places. And we would have our final graph. So this is about as bad as it gets when your phase shift that you're trying to do doesn't match your scale, so you have to get a common denominator and subdivide your scale if you want to draw a really accurate picture.